Hello everyone. By now we have learned many things in trigonometry. Starting from unit circle, we defined sine theta, cos theta. Then we extended to graphs of trigonometric functions, trigonometric identities. Lots of things we have gathered by now. And now in this particular video, I will be taking certain things which are in the formulae form. Frankly speaking, from JE point of view, for whom like I make most of the time videos, for them I don't think anywhere formula derivation is required, but more than that application is required. So I may not be covering the derivation part of formulae, so please forgive me for that. And those who are interested in knowing the proofs of those formulae, they can write in the comment section their requirement and I can get back to them separately. So in today's video we will be talking about the trigonometric ratios of sum and differences of angles. Like, now first in that is sine of a plus b, which is sine a cos b plus cos a sin b. I'm directly giving to you as the formula what stands for sine of a plus b. Anywhere you get sine of a plus b, you can expand it as sine a cos b plus cos a sin b. Similarly, we can have for sine of a minus b, that is sine a cos b minus cos a sin b. Certain small explanations wherever required, that I can give to you. Like, here we have sine a cos b plus cos a sin b, and now on left hand side you had here plus b, but in the second one you have here minus. So to derive second from first, what you can do is, in the first one replace b by minus b, and then perhaps you may get the second one. This is just a hint. Those who want to actually work out, they can work out for themselves. Now this is about sine a plus b and sine a minus b. Similarly, I can write formula for cos a plus b and cos a minus b also. Cos a plus b is cos a cos b minus sin a sin b, and cos of a minus b is cos a cos b plus sin a sin b. These are four important formulae which you will be using left, right and center. So like, either you just remember it by heart or you write it 4-5 times and 7 times. I'm sure you will remember them. I mean, no special effort is required, but certain small hints I can give. Like in sine formula, you can see, I mean, how to remember for that, that it is always in the form of one sine and one cos term. And here also you find one sine, one cos term. Even in the second one you are finding. But in cos formulae, on the right hand side, if you go to see, you get product of two cos terms and product of two sine terms. I mean, this is just one hint, like how to remember. Rest choice is yours. You can find out your own shortcuts to remember them. So we have covered here sine a plus b, sine a minus b, cos a plus b, cos a minus b. Some small examples I can take for you, like how to use them. My first example is how to find sine pi by 2 plus a. Now understand one thing, sine pi by 2 plus a, we will have separate video for such type of formula also, that sine pi by 2 plus a. These are called allied angle formulae. Let us not discuss that in detail here. I will give you separate video on that also. Now if I have to find out sine pi by 2 plus a, I can go for this sine a plus b formula and then I can start simplifying it. So sine pi by 2 plus a by formula of sine a plus b would be sine pi by 2 cos a plus cos pi by 2 sin a. I have just substituted here in place of a as pi by 2 and in place of b I have substituted a. And you substitute value of sine pi by 2, that is 1, cos pi by 2 is 0, and simplify it further, that leads to cos a. So my answer for sine pi by 2 plus a is cos a. Now this you may have separately as a formula also, sine pi by 2 plus a as cos a. Now let me take one more example where you can use this one of the formulae. I am taking cos pi by 2 minus a, so that this at least one cos formula you will be able to use. Now again I will be using cos a minus b formula. In that, in place of a I will substitute pi by 2 and in place of b I have to write a. So I go for this formula. I will write cos pi by 2 cos a plus sin pi by 2 sin a. Again replace cos pi by 2 by 0 and sin pi by 2 by 1 and simplify it further. That leads to answer as sin a. So cos pi by 2 minus a is sin a. Like that, if you wish, you can actually work out yourself that how to write cos pi by 2 plus a, or how to write sin pi by 2 minus a, etc. You can get more formulae also in the list, but if you wish, I can have separate, like video for that. Okay. Now I move further from here and I go to tan formula. Now tan a plus b is tan a plus tan b upon 1 minus tan a tan b, and tan a minus b is tan a minus tan b upon 1 plus tan a tan b. Now to get tan a plus b, one method is that you write it as sin a plus b upon cos a plus b. You write those formulae, what I have given just now, in place of sin a plus b and cos a plus b, and divide everywhere in numerator as well as denominator by cos a cos b. Simplify, you will get this as right hand side. That is tan a plus tan b upon 1 minus tan a tan b. I have just instructed you, those who are interested in derivation part, they can do this and check for yourself, verify yourself, that do we get tan a plus tan b upon 1 minus tan a tan b for tan a plus b. Similar is the case with tan a minus b also. Sin a minus b upon cos a minus b. Simplify by formula, write the formula for sin a minus b and cos a minus b, and then divide by cos a cos b. You will get answer as tan a minus tan b upon 1 plus tan a tan b. So this is about tan a plus b and tan a minus b. Now let me take one example just to have more clarity if you wish. Tan pi by 4 minus a. If I have to evaluate this, I go for formula of tan a minus b, and using this I will be writing tan a minus tan b upon 1 plus tan a tan b. So in place of a, I will be writing pi by 4, and in place of b, I will be writing a. So I rewrite it as, and I will get this as tan pi by 4 minus tan a upon 1 plus tan pi by 4 tan a. Tan pi by 4 means tan 45 degree, that is 1. So simplify it further and you will get answer as 1 minus tan a upon 1 plus tan a. So answer for given expression tan pi by 4 minus a is 1 minus tan a upon 1 plus tan a. Now again, here I am taking this as just one example. In my previous videos also, I have been saying this again and again. I do take as example, but they are standard results. So like in some of the questions, if tan pi by 4 minus a you get somewhere, then you may have to start with 1 minus tan a upon 1 plus tan a directly and skip these steps. From JE point of view, I am telling. But if you are writing your 12th standard or 11th standard examination, school, college examination, then you will have to show all these steps. But otherwise, from JE point of view, I am saying you get anywhere tan pi by 4 minus a, you straight away write 1 minus tan a upon 1 plus tan a. Similarly, for tan pi by 4 plus a, you will be getting 1 plus tan a upon 1 minus tan a. That also you can work out for yourself. Now this was about sin a plus b, sin a minus b, cos a plus b, cos a minus b, tan a plus b, tan a minus b. I mean, two angles were included, a and b. Now I go for sum and differences of three angles and trigonometric ratios of them. So in the list, first is sine of a plus b plus c, and that is nothing but sigma sine a cos b cos c minus product sine a. Now sigma is this symbol and product is this symbol. Now this sigma suggests us that there are going to be more terms here, which would be nothing but the sum. This sigma stands for sum, and this notation capital pi tells us that this is nothing but a product. So this is not sine a, but a product which has terms like sine a. And now this summation part tells me that there are going to be more terms in which terms like sine a cos b cos c are going to be there. If you see this term carefully, this tells me that cos b cos c product is appearing there, and to that product you are multiplying by sine a. So one sine term and two cos terms are appearing there. Now like this, some more terms are expected. So let me write that separately. I write sigma sine a cos b cos c as sine a cos b cos c, that is the first term, plus next term I write as cos a sin b cos c. Means what I did, now that sine which was attached with a, now I am writing with b. Okay, and now there would be third more term, that would be cos a cos b sin c. And now if I try to further shuffle, I will go back to this first term only. So there are only three terms under this summation notation. So in place of sigma sine a cos b cos c, actually I could have written this bigger expression. But understand one thing, that would be too large to handle while writing also. So it is better that you write just one representative term. So in mathematics, at many places you will find that we try to write the expression in more concise form. So this is that concise form. By writing here sigma notation, we made it in more concise form. Now, what about product sin A? That also will have to be seen. Like in product sin a term like sin A, and it would be product. So what are the other terms? Other terms are sin B and sin C. So the entire product sin A, sin B, sin C can be written in more concise form as product sin A. So now you know sin A plus B plus C is sigma sin A cos B cos C minus product sin A. So actually this is going to have 4 terms in it. Okay. Now I go for cos A plus B plus C. That is product cos A minus sigma sin A sin B cos C. Again, similar expression you can have. Now this is one term where 2 sin terms are in product and 1 cos. So similar more terms you can write under this sigma, and you will have a bigger expression here, and product cos A would be replaced by product cos A cos B cos C. Okay. Now similarly I can write for tan A plus B plus C also. That is tan A plus tan B plus tan C minus tan A tan B tan C upon 1 minus tan A tan B minus tan B tan C minus tan C tan A. Now understand one thing. Now this tan A plus B plus C is actually this big expression sin A plus B plus C divided by cos A plus B plus C, and then dividing by some cos terms, etc., and then simplify. Then you are going to get it. So I'm not showing the derivation part as I said before. Now directly I'm writing this as formula. Now understand this. Now I have tried to write here the entire expression in terms of tan A, tan B, tan C separately. Now, if I wish, I can write this in more concise form and see how beautiful it looks. You don't have to write this big expression. Instead of that, you can simply write this as sigma tan A minus product tan A upon 1 minus sigma tan B tan C. Now, sigma tan B tan C will have more terms here, not just tan B tan C. What type of terms? That here you are taking product of 2 tan terms. I have written now B and C combination. You can write C and A combination also, and you can write A and B combination also. So there would be again 3 terms here. Now you know product tan A, that would be tan A, tan B, tan C, and this sigma tan A means this tan A plus tan B plus tan C, that you know now. Okay, so I have written here tan A plus B plus C, cos A plus B plus C, and sin A plus B plus C. Please rewrite them in your notebook, and then only they would stay in your mind. Just by reading them as formula, you won't be able to solve problems. For problem solving, all the formulas should be there at your fingertips. Okay, I further move and I go for the next one, and that is now some results which I am trying to find out from the previous formula what I have given you just now. Now my first corollary means the result what you try to find out from certain main results, right? Now A plus B plus C equal to n pi is equivalent to sigma tan A equal to product tan A. Now A plus B plus C equal to n pi. Remember that formula tan A plus B plus C just now we have done. Now if you write A plus B plus C as n pi, then your left hand side in formula of tan A plus B plus C will become tan n pi, which is 0. So this result has been obtained from formula of tan of A plus B plus C. So your numerator there would become 0, and that leads to sigma tan A equal to product tan A. So this is again one important formula. Every time we are not going to start with tan of A plus B plus C and then writing formula and then substituting. No. Now this becomes a standard result now. Now somewhere some problem maybe like started with A plus B plus C equal to n pi is given to you, and you write their equivalent statement as sigma tan A equal to product tan A, and maybe in your next step you get your answer also straight away. So know where the entire formula is to be written. Okay, this is just one corollary which I have found from tan of A plus B plus C formula. Okay, now this further corollary stands for n equal to 1 also. This is any value of n you can give here. So that would lead to one nice result. If A plus B plus C is pi, after substituting this n equal to 1, A plus B plus C equal to pi means A plus B plus C equal to 180 degree, which is related to a triangle also. So in a triangle, I can write that sigma tan A equal to product tan A. You know what happens when results in trigonometry which are related to triangle, somewhere we straight away write sigma tan A equal to product tan A because it is related to a triangle. And then students feel that how do you write directly? See how much is the link. It starts from tan A plus B plus C, then this corollary, and then further result appearing from this corollary. But this becomes somewhere the initial step of some question. So this is how we have to skip the formula part and further results and come to the straight first term itself, first step itself. Many students feel that how do you know that question is to be started from here? So this is the preparation what we do by seeing the videos again and again. Okay, so in a triangle ABC, sigma tan A equal to product tan A. This is also one important result which you have to remember. Okay, I go further, and now I will be writing that tan A plus B plus C in a different form. I write S1 as sigma tan A. I write S2 as sigma tan B tan C. I write S3 as product tan A. And then I would be writing tan A plus B plus C in terms of now S1, S2, S3. And that actually turns out to be S1 minus S3 upon 1 minus S2. Now understand one thing, term by term we would discuss this. This is S1 equal to sigma tan A. Now sigma tan A means tan A plus tan B plus tan C. This was there in our formula. S2 I'm writing for sigma tan B tan C. And S3 I'm writing for product tan A. Product tan A is known to you. That is tan A tan B tan C. Sigma tan B tan C also is known to you, where we will be writing a sum in which terms like tan B tan C would appear. So here I have written B and C combination. Then there would be a combination of C and A and another combination of A and B. So there would be 3 terms under this S2 also, right? Now what we had written for tan A plus B plus C before in sigma and product notation, I am trying to write this further in more concise form here by writing it as S1 minus S3 upon 1 minus S2. Now, some of you may say that why we have written this 1, 3, 2 as those suffix. Now, I read this sigma tan A, sigma tan B tan C, and sigma and this product tan A as. Now, understand this wording what I will be using now. I will say product of 3 terms at a time, product of 2 terms at a time in S2, and I write for S1 as, I consider this S1 as product of 1 tan term at a time. Means in S1, product of 1 tan term, S2 product of 2 tan terms, S3 product of 3 tan terms. Now you will understand why I am writing here 3, 2 and 1 as suffix. How many terms of tan you will be taking in the product, that I am just mentioning here, so that the moment you see this S1 minus S3 upon 1 minus S2, you will be able to understand that in S1, this would be sum of product of 2 tantrums or 1 tantrum or 3 tantrums. 1 suggests me here 1 tantrum, 3 suggests 3 tantrums, and 2 suggests 2 tantrums. So this is how I have written in my new notation tan of A plus B plus C. This notation actually is extremely useful when this sum becomes of more angles. Means instead of 3 angles, if you have 4 angles or 5 angles or 6 angles, you should be able to write. So I go further from here as tan of A plus B plus C plus D. That means I will be writing now for 4 angles. And for that I write as S1 minus S3 upon 1 minus S2 plus S4. Now certain rule or certain pattern you can see here. First of all, numerator has suffix where odd suffix is appearing like 1 and 3. And in denominator, we are observing that even suffix is appearing. Okay, so all odd ones would be kept in the numerator and the even ones would be kept in the denominator. This is first thing what I observe. And secondly, seeing the tan A plus B plus C plus D's answer, the denominator especially, I would say that alternate signs are appearing like minus here, then comes first plus. Now I'm sure when you go for A plus B plus C plus D plus E plus F etc., then S6 will appear, and that would come as minus S6. This I'm just giving you as a hint. I will not go till there, but just I'm saying. Okay, so similarly I can write for 5 angles. Tan of A plus B plus C plus D plus E would be now S1 minus S3 plus S5 upon 1 minus S2 plus S4. Now here also you observe that minus and plus signs are appearing alternately. Same way in the denominator also minus and plus signs are appearing alternately. So this is how we write for tan of sum of 5 angles. Now understand one thing, you can write for 10 angles also in this way, but it may look simpler, but it is actually not simple to write. When you would expand, that would go out of control. It is only for understanding that the pattern would be something like this, that S1 minus S3 plus S5 upon 1 minus S2 plus S4. The moment you go for seventh angle, here S7 would be appearing with minus sign, and here minus S6 would appear, and so on. So you can understand if you go for 10 angles, how big that expression would be. Okay, now let us not go actually there, but understand that we can write formula in more concise form. So in this video, we learned now sine and cosine formulae for a plus b, a minus b, a plus b plus c, and tan formulae for a plus b plus c, a plus b plus c plus d plus e also, right? Now, please revise them, and I will be getting something new in my next video. Till then, stay tuned. Thank you.